Hello, welcome to Learn with Lakineni. Now we are coming with another subject, formal long base and automata theory. So this is a very important subject for computer science engineering students. So in GATE point of view also, this subject is very important. So keeping this point, we want to make videos on formal long base and automata theory from basic concepts to all the concepts in flat. And also we will solve various examples, and also we will solve gate questions on formal long base and automata theory subject. So these videos will be helpful for any type of university student. We will clearly explain all the concepts and we will do more practical examples, and every example will be explained clearly with the solving capabilities for gate examinations also. So please watch all these videos. Please subscribe to my channel, Learn with Lakineni. Please like it, share to your friends. Please watch all the videos. Thank you. Thank you for watching my videos.
In this video, I am going to explain you about what is a finite automata. So, in the previous video, I have already discussed what is an automata. An automata is a abstract machine which is a computational model. Its duty is to take the inputs from the input string, and accordingly it changes from one state to another state, and finally it settles at some state. If the settled state is a final state, then we treat the string is accepted. Otherwise, the string is not accepted. So, it is purely an abstract mathematical computational mission. You can think of like this. It is an imaginary mission which we are designing in such a manner that your strings are accepted or rejected. So, string means a long ways, whether the long ways is accepted or not. So, we will see the complete formal definition of what is a finite automata. Before that, why it is a finite? Always you have finite set of states. You will never have infinite set of states. That means you will have a limited number of states, either 10, 20, 5, 6, 10, whatever it may be. The states are countable. That means they are finite. So here, when you go through the proper definition of finite automata, a finite automata consisting of finite set of states and transitions from one state to the another state basing on the input symbols over the alphabet sigma. That means a finite automata has some states and it changes from one state to the another state. The changing from one state to the another state is called as transition. So how the transition will happen? Basing on the input. Suppose if you take a finite automata, suppose there are some states Q0, Q1, Q2. So always we represent the states with a circle. It is customary to represent the states with circle. So these are the states Q0, Q1, Q2, where Q0, Q1, Q2 are the names which I have given to the states. You can give any name, it's no problem. So here from Q0 to Q1 I am changing. How I am changing? By taking some input A. So from where I am taking this input? From the given alphabet. Let us suppose I have an alphabet sigma A comma B. From this alphabet I have taken one alphabet, that means one symbol. Basing on that symbol I am changing from one state to the another state. This changing from one state to another state is called as transition. Transition. This is called as state. This is called as input symbol. From where you are taking? From the alphabet. Input symbol from the alphabet. Like that, we are taking the input symbols from the given string, and accordingly we are changing from one state to the another state, and we are making some state as a final state. always the final states are represented with a double circle. Here we have to represent the transitions with the arrow mark. So arrow mark shows from which state to which state you are going. So here if you see this arrow mark indicates that we are going from state Q1 to Q2. Okay, so here just I am giving the basic introduction of what is a finite automata. Why it is finite? Because always the number of states in the given diagram are finite. So here a finite automata consisting of finite set of states and a transitions from state to the state that occurs on the input symbols taken from the alphabet sigma. For each input symbol, there is exactly one transition out of each state. That means you have taken one input symbol. For that input symbol, there is exactly one transition from some Q1 to Q2. That means some one state to the another state. Let us suppose I have taken a state input symbol A. On that input symbol, I have made a transition. That means I have moved from Q0 to Q1. That means this is one transition. So each input symbol has exactly one transition out of each states. One state usually represented with Q0. Usually we represent the initial state. That means where your journey starts, where your automata starts changing from one state to another state, that is called as initial state. Usually initial state is denoted by Q0, in which the automata starts. Remaining states are represented with your own numbering Q1, Q2, Q3, so on. You can give it your own number. So if we see the mathematical definition of an automata, we will call an automata is a phi tuple. We will call our automata is a phi tuple as per the mathematical representation of an automata. So here the formal definition of an automata is phi tuple Q, sigma, delta, Q0, F. So these are the 5 symbols. This is called as phi tuple. The mission can be, the finite automata mission can be represented with a, suppose if we let us suppose that our finite automata is a mission. It is a mission. This mission can be represented formally as Q, sigma, delta, Q0, and finally F. So here this is called as phi tuple. This is called as phi tuple, where Q is the set of states, the set of states in the machine or the finite automata, in the finite automata, or you can call it as a mission. What are the number of states you have defined? All those states comes under Q, the set Q. So Q means the set of states in the given finite automata. Sigma means alphabet, input alphabet. That means you can call it as input symbols. And delta means a transition rule. Delta means a transition rule. That means how you are changing from one state to another state. That rule is called as transition rule. So here the delta can be represented as delta maps. You are taking one state from the Q and you are taking one input symbol from the alphabet and you are going to some other state in the same Q. That means delta maps Q cross sigma to Q. That means suppose if you have, let us suppose if you take this example, in this example you have 3 states, Q0, Q1, Q2. So this is your Q. In this Q you are taking one state, either Q0, Q1, Q2. On that state you are applying your input symbol. That means your input alphabet. Let us suppose your input alphabet is A, B. That means you are applying input A on Q0 or Q1 or Q2. Similarly, either Q0 on B, Q1 on B, Q2 on B. And finally, you are going to, where you are going? You are going to some other state. Those states also will be in Q only. Whatever the states in Q are there, in those states only you are going. This is again Q. That means you are taking one state and you are applying any of the input and you are going to one of the states of the same Q. So this is what is called a transition rule. So delta maps Q cross sigma to Q. And Q0, every finite automata has an initial state. It starts its journey at some place, at some state. The initial state is called as, for every finite automata you have an initial state. Here we are defining the initial state with Q0. So Q0 is initial state. Without initial state you cannot design the automata. Initial state. And finally F is a set of final states. Set of final states. Automata may have one final state or more than one final state. So that's why you can say F is subset or equal to Q. F is subset or equal to Q. That means final state is also one of the states in Q itself. So final states may be 1 or 2 or more than 1. So that's why you can define F as a set of final states. F is subset or equal to Q. So this is the formal definition of what is a finite automata. So a finite automata is a mission with 5 tuple: Q, sigma, delta, Q0 and F. So where Q is the set of states in the given finite automata, where sigma is input alphabet symbol, delta is a transition rule which maps Q cross sigma to Q, and Q0 is initial state, and F is the set of final states. F is subset or equal to Q. So this is the definition of finite automata. If you see here, so here sigma Q, sigma, delta, Q0, F. So Q is a set of final states, sigma is an input alphabet, and Q is a delta is a transition Q cross sigma to Q. Q0 is initial state, and F is a subset or equal to Q, which is a set of final states. You can have more than one final state in a given. Sometimes you can have one final state, sometimes depend upon the requirement, depend upon the problem statement, you can have one final state or more than one final state. Sometimes all the states may be a final state. It's all depends upon the requirement of the language and the strings. Next, transition diagram. So already I have shown what is a transition diagram. So this is the transition diagram. So how you are moving from one state to another state. So this is one state, this is another state. You are moving from Q0 to Q1 by taking the input A. So this is what is called transition diagram. This is the transition diagram. Every time you have to show the initial state like this. This indicates that this is an initial state. So you are transiting from one state to the other state. You are moving from one state to the other state by taking some input. Without input, you can never go to from one state to the another state. So suppose here I have an initial state Q0. Every time you have to represent the states with circle Q0, Q1, Q2. So this is an initial state. So I am representing with this arrow. Let us suppose this is the final state. Now I am moving from Q0 to Q1. How I am moving? By taking an input A. Suppose I am moving from Q1 to Q2 by taking an input B. So this is called a transition diagram. This is called as a transition diagram. Or we can call it as a finite automata transition diagram. So here these are the transitions. This arrow mark indicates from which state to which state you are going. So this indicates I am going from Q0 to Q1. Suppose if I have like this, arrow mark will be in the reverse direction with input B. That means I am going from Q1 to Q0 by taking the input B. So this is called a transition diagram. If you see the information about the transition diagram, a transition diagram is a directed graph associated with the finite automata in which the vertices of the graph correspond to the states of the finite states. It is a directed graph. You have to show the directions. That means from which state to which state you are going. If there is a transition from state Q to state P on the input A, then how you will show state Q to state P on the input A. So this is the transition. This is a directed graph. You have to show the directions. This is what is called a transition diagram. So transitions are denoted by this arrow mark, and initial state is denoted by like this, and final states are denoted by double circled. If any state you are choosing as a final state, you have to represent that state with a double circle. So this is what about a transition diagram. Now we will see the transition table. So for every transition diagram, there is a transition table. So transition table shows how we are going from one state to the another state on taking the input. That means transition table can be drawn from the transition diagram. So a tabular representation in which rows correspond to the states and columns correspond to the inputs and entries corresponds to the next states. That means from where on which state and which input where you are going. Rows corresponds to the states, columns corresponds to the input symbols. The entries in the table represents the next states. Suppose I have a diagram like this. I will take one diagram, Q0 and Q1 and Q2. Let us suppose this is the final. Here, this is an initial state. Q0 on A, I am going to some Q1. Q0 on B, I am going to some Q0. Q1 on A and B, I am going to Q2. Q1 on A, I am going to Q1. On Q2, I am going to, with A, I am going to Q1. And with B, I am going to Q1. Suppose this is the transition diagram. For this one, I will write the transition table like this. Transition table. Transition table consisting of rows and columns. Here, this is an input symbol. This is the states Q. What are the input symbols here? A and B. Columns are the input symbols. How many states are there? Q0, Q1, Q2. Rows are the states. So what is the entries? Entries are the next states. So what happens when you take Q0 on A? So what happens on the state Q0 when you see the input A? On the state Q0, if you see the input A, you are going to state Q1. So this is the entry here. What happens when you see B, the input B on Q0? Suppose if you see the input B and Q0, you are going to the state Q0 itself. You are going to the same state Q0. What happens if you see A on Q1? If you see A and Q1, you are going to the same state. What happens if you see input B and Q1? If you see input B and Q1, you are going to state Q2. Similarly, what happens if you see A input on Q2? You are going to Q2 only. What happens if you apply the input B on Q2? you are going to state Q1. You are going to state Q1. Here, in the transition table, the final state will be represented like this. You have to represent which state is the final state. The initial state is represented like this. This is a input alphabet. So this is what is called the transition table for the given finite automata or transition diagram. So this is what the transition table. This is what is called as transition table. Here rows represents the input symbols, columns represents the states, the entries, these are all entries. These entries represent what is the next state on taking the input symbol on the current state. So this is your current state. This is your input symbol. Where you are going? You are going to Q1. This is your current state. On input symbol B, where you are going? Q0. So these are the next states. So we are reading the input symbols from the input tape. Here you have an input tape. So let us suppose this is the input tape. In the input tape, you have symbols. Let us suppose A, B, B, A, B. So this is the string. So here you have a head, read head. You have a read head. So that read head is reading one by one input symbol from the input string, and according to the input symbol, the control is changing from one state to the another state. We will see the formal information about what is an input tape. So here input tape means the input tape is divided into squares, each square containing a single symbol from the input alphabet. So here this is the input tape. Here you have number of cells. In that you have your string. This string is designed from the sigma. So your read head will read the symbols from this input tape and it sends to the control unit. The end squares of the tape contains the end marks at the left hand and the right hand. So here the tape is always infinite tape. Here always the tape is infinite tape. Suppose here this is your string A, B, A, B. So here the remaining are filled with epsilons. That means blank symbols. All the remaining cells are filled with blank symbols except your string. All the other ends are filled with epsilons. This is called as blank symbols. Some people will fill with epsilon. Some people will show with capital V. Some people will show with dollar symbol. Any of the notations is accepted. Whatever the cells you fill, you just fill. The remaining cells are filled with empty symbols. The options of end markers indicate that the tape is of infinite length. The left to right sequence of symbols between the two end marks is the input string to be processed. So here, let us suppose this is my tape of infinite length, in which I have my string A, B, A, A. So here I am marking with some dollar. Here I am marking with some dollar. So these $2 indicate that your string is from here to here. Otherwise, you cannot recognize where to stop. Here these end markers will indicate that your string is ended. Always we will travel from left to right. You are traveling from left to right. You will read this input and the read head will go to the right side. One step right side. Again, after reading this input, your read head will move one cell to the right side. Like that, up to you reach the end mark, your read head will move from left to the right each time, one cell at a time. So this is what the input tape. Always your input will be supplied. Your input string will be supplied from the input tape. Here you can see the head examines, reading head. The head examines only one square at a time and can move one square either to the left or to the right. So the read head can move either to the left or to the right, one cell at a time. But in most of the cases in our finite automatas, we will move from left to the right. So already I have informed that most of the cases we restrict the movement of the read head only to the right side. Most of the finite automatas will move the head from left to right by reading one input symbol from one cell at a time and moving from left to right one cell at a time. And finally, finite control. So this is the heart of your finite automata. After reading the input from the input tape, the read head will send the input to the finite control. Now the finite control, basing on the input on the present state, it will move from one state to the another state. So the input to the finite control will always be the symbol under the read head. So whatever the read head taken the input from the input tape, basing on that input symbol, it will move. Say let us suppose A, and the present state is Q. Then it moves. That means if your present state is Q and read head is reading the input symbol A, so now on input A, it moves from Q to the next state. So a motion of reading head along with the tape to the next square. Okay, the next state of the final state mission will be given by delta of Q comma A. That means this is your present state and this is your present input symbol, and delta will tell where to go to the next step. So delta is a transition from where to where. Delta is a transition on taking the input on the present state Q and taking the present input symbol A. So where to go? So let us suppose I am going to the state P. So delta will define where to go. So the next state of the final state mission given by the delta. So this is what a finite control. Now we will see the entire architecture of or the diagram of a finite automata. Now we will see the architecture of a finite automata. Here you have an input tape in which you have a string A, B, P, A. So this is your read head. Read head is always pointed to the leftmost symbol in the given string. So the leftmost symbol in the given string is A. So the remaining cells are occupied, except the string, the remaining cells are occupied with some dollar symbols. That indicates that the string is ended. So here read head is reading the symbol A from the input tape. Why it is called read head? It can only read. It cannot modify the symbols in the given input tape. It cannot modify. Whatever the input symbol is there, its duty is to read only. It reads and it sends to the control unit. So upon seeing, let us suppose what is the first symbol A. Where is your current state? Let us suppose your current state is Q0. Upon seeing A on Q0, your control unit will decide where to go. So let us suppose upon seeing Q0 on A, then it is going to, let us suppose, Q1. It is going to Q1. So this is what is called delta rule. Delta, your present state is Q0, your present symbol is A, and delta defines that you have to go to the state Q0, Q2. So this is rule, delta rule. This is called as delta rule. That means it is a transition from where, what is your current state, what is your current input symbol, and where you have to go. So this is called as transition rule. Transition rule. Like that, after reading A, your head will go here. After reading B, your head will go to the B. After reading B, your head will go to the A. It reads and supplies to the control unit. It reads one symbol and it supplies to the control unit and changes to next cell to the right side. After reading all the symbols from the input tape, if let us suppose Q3 is the final state. After reading all the symbols, if you are at Q3, then we can say that your string is accepted. Final state means if the string is as per the long ways requirements, then you will be on the final state. That means your string is accepted. This is a basic architecture of what is a finite automata. So in finite automata, you have input tape and read head and control unit. Your read head will read the inputs in the input tape one by one at a time from left to right. Whatever the input it has read, it will be supplied to the control unit. So in the control unit, it decides in which state it has to go based upon the transition rules. So this is the entire detailed information about what is a finite automata. So acceptance of the string. When we will say your string is accepted, so after reading the entire string, after reading your entire string, let us suppose your string is x. Your string is x. Suppose this is your delta. Your initial state is q0. Your entire string is x. After reading the entire string, finally if you are at q, if that q belongs to the set of final states, if the q is in final state group, then you can call the string x is accepted. The string x is accepted. So when you will say that the string is accepted, after reading all the input symbols from the given input string, and if you are finally if you are at state q such that if that state belongs to the final state, then we can call the string is accepted. A final state is also called an accepting state. If after reading the entire string, finally if you are at some state, if the state is in final state, then it is called as accepted state or final state. Then you can call your string is accepted by the finite automata. So here, suppose I have a transition. I have my present state is q. Now in my string I have two symbols. In my string I have two symbols. Then I can write like this: delta of. First, initially I have to apply the transition on the leftmost symbol. I have applied delta on x. That means the input symbol x on the present state q. After that, again I will apply delta on the next input symbol y. So this is what the transition happens. A transition function delta for any two input string x and y. That means there are two inputs symbols in the given input string. Then delta of q comma x comma y can be written as delta of q comma x. After going to the next state, again you are applying the y on the next state. So this is the way of deriving the string and checking the string acceptance. We will see one example now. Let us see one example of acceptance of a string. This is a transition diagram or finite automata. Let us suppose I have a string w is equal to a, b, b. Now I have to check whether this string is accepted by this finite automata or not. So first of all, we will see the transitions as delta of what is your present state? Your present state is q0. What is your string? Your string is w, which is equivalent to, this is the symbol equivalent to delta of q0. What is your string? Your entire string is a, b, b. This is your string. On the string, you will never see the remaining inputs. First of all, always you can see the leftmost symbol. This only you can see. Now, so you can apply the symbol a on q0. After applying the symbol a on q0, where you are going? After applying the input a on q0, where you are going? You are going to q1. The next state is q1. So again write delta. Now you are going to q1. Now this symbol is consumed. Now the head moves to here, to the left side. Now what is your present state? Your present state is q1. What is your present symbol? Your present symbol is a. Now what happens? Now your present symbol is A. What happens? A on Q1. So if you give A, input A and Q1, again you are going to the same state. Again you are going to the same state. That means delta of Q1 comma, this symbol is consumed and the read head moves to the right side. Now B. Now what is current symbol? B. What is your current state? Q1. What happens? The input B on Q1. So when you give input B and Q1, you are going to Q2. You are going to Q2. Now delta of, now you are changing to Q2 and this is consumed. Now the next state is B. Now what happens when you consume B on Q2? So if you apply B on Q2, again you are going to the same state. That means you are going to Q2. Now this symbol is also consumed. So suppose if you see the input tape, what happens? You can let us suppose your input tape consisting of A, B, and the remaining cells are filled with epsilons. Now we have initially taken A, of that you have moved to the right side, again A, of that again you have moved to the right side, and again you move to the right side. After consuming B, again your head will move to the right side. So after B, what is the symbol is there? The symbol is B. So whenever the head sees the symbol epsilon, there it stops and declares the present state as the state it has halted. Now where you have halted, where you have stopped? On Q2 you have stopped. Now if this Q2 belongs to the final state, then your string is accepted. Yes, in our final Q2 is a final state, so that's why your string is accepted. So like that you will check the acceptance of a string. If this Q2 is not a final state, then your string is not accepted. Your string is rejected. So like that you have to check the acceptance of a string by designing the finite automata.
Thank you all. Thank you for watching this video. If you really like this video, please subscribe, like, share, comment on my YouTube channel. In future, we are going to create many more videos on computer science engineering subjects. Thank you.